We want to know why a t-test is robust and resistant to outliers. We're going to run a test where we're testing the alternative hypothesis that the mean is greater than 150 seconds to package 200 maps. You can see the dot plot up here. It doesn't give us any reason to doubt that it could come from a normal population. We put the data into a list, and then we ran a z-test and a t-test using that data. And these were the results. You can see that the z-test and the t-test were very similar. What we did was, if you look at the t-test, the sample standard deviation was 5.855 seconds. And so we just assumed that that was the population standard deviation for the sake of being able to do a z-test. But then I wanted to add an outlier to the data set to see how it affects things. So we see that 180 is an outlier. Well, what happened to the z-test? Well, the z-test, because we had to leave the standard deviation at 5.85, because we're assuming that's the population standard deviation, well, now the mean average got kicked up to 156, so that's twice as many standard deviations away from the mean as it was before, 3.26. P-value goes way down, we reject the null. But here's what's nice about the t-test. We add that 180 into the data set and we recalculate the standard deviation. The sample standard deviation goes from 5 point something way up to 10.85. Our sample mean increases, but if you see where the blue arrow is, the difference between 156.75 and 150 is bigger than it used to be, but so is the standard error of the means. So that's why we're still only 1.76 of the new standard errors away from the mean, and the p-value doesn't change that much. It's 0.06. If you look at this, here's what happens with the z-score. Because the standard deviation of the population stays at 5.85, the standard deviation of the means is 2.06. This is what the normal distribution looks like, and our new sample mean of 156.75 is off the right tail. But with the t-distribution, we recalculate the standard error of the means at 10.85, so you've got to make it 3 of those standard deviations, 3.83 standard errors actually, above the mean. So it's a more spread out t-distribution. You got to get way out there to 161 to make it out to the tail. So even though our sample mean is bigger, it's in a t-distribution that has a much bigger standard error of the means, and so that is the reason why a t-distribution is robust and it's resistant to outliers. So that's why we talked about in the last video why we're allowed to say, hey, we got a small sample size, but the distribution is like fairly symmetric with no outliers, and after all, the t-test is a robust test, so we're going to go ahead and trust our results. That's the kind of thing we're talking about. Now, typically we would say the sample needs to be 15 or more with no outliers present. We're real confident that we're going to get a good result. But even with this, we can see, heck, a small sample size with an outlier didn't really affect it much. So we love the t-test.